Hello and welcome back to the Redox Connection. I'm Liana, I'm a holistic wellness coach, and I just love inspiring and assisting others tap into their full potentials in order to live a happy and fulfilled life. The Redox Connection comes about, and we are so honored to have Dr. Ray Dixon with us today. Hi, Dr. Ray. Because in these series, we dive into understanding better the functions of our body so that we can take responsibility and take care of ourselves. Now, we've discussed in a previous series about the cardiovascular system with Dr. Ray, who's a chiropractor, naturopath with 40 odd years, plus years of practice, and one of the world's first redox educators, about how the cardiovascular system works. And we found so many interesting little nuggets there. So I really invite you to go back, look for that video, listen to it, that episode, so you can understand the amount of work it actually does. Dr. Ray in that episode discussed just little tips on how we can support a healthy functioning system. And today instead, we're going to focus on disorders in the system. So what is the main disorder, Dr. Ray?
Main disorder. Well, the number one killer in the Western world is myocardial infarction, otherwise known as a heart attack. And in the top three killers in the Western world is strokes. They're both really, when I used to teach this in pathophysiology to students, I used to say they're really the same types of problem. They're just in a different department. So, if, for example, a myocardial infarction or heart attack, as most people know it, is when you form a blood clot in the coronary artery or blocking the blood supply to that myocardial wall, which is doing your pumping for your heart. And that's essentially what a heart attack is. You've formed a clot from probably years of developing atherosclerosis and plaquing of those coronary artery walls. And then that creates a roughened edge, if you like, fatty, which triggers a clotting response. And then when you finally form a clot, it will block that artery and where the blood is going. Now, certain parts of the heart, that one perhaps coronary artery is only exclusively supplying certain parts. Other parts can be collateral. There can be a number of pathways. But if it happens to be exclusive, then you're in trouble because you're now not getting oxygen and nutrition and what those cells need to function and be healthy being delivered. So therefore, those cells enter necrosis and die. And as we said in that last call, cardiac myocytes are considered not able to reproduce themselves. Now, there is some stem cell research going on to indicate that maybe we can overcome that problem. But the basic knowledge to this day is that if you kill off cardiac myocytes, you're generally not going to replace them with healthy cells, even if you survive. It's going to be scar tissue. So now, as far as the brain and strokes is concerned, now just imagine the same problem in the brain forming a clot. Well, that's a stroke. So the 80% of cerebrovascular accidents, which is the term for strokes, is actually due to a clot. 20% is the opposite. We rupture a blood vessel and you bleed into the brain. They are much more severe and serious with much worse consequences, but they're the 20% category. Also, the 80% category is actually the blood clots. And now you can see why I equate the two to each other. It's just that similar causes in terms of high blood pressure and atherosclerosis, generally speaking, just a different organ where the clot occurs.
Right.
So those are the two main disorders, but there's a whole variety of others, of course.
Right, and that was you touched it briefly, but the causes, what causes this, the blood clot?
Well, again, I was halfway there when I mentioned the roughened inner endothelium of blood vessels. So it's the endocardium that lines the inside of the heart. It's the endothelium that lines the inside of blood vessels, including arteries. Now, the endothelium faces into the lumen, the space where the blood travels through. So over years, though, that endothelium can be hardened. That's called arteriosclerosis, or it can get thickening due to fatty plaques and cholesterol, atheroma or atherosclerosis. And obviously that narrows the passage in the blood vessels. And it's really extraordinary how the body can cope with a certain amount of that for a very long time. But eventually, that triggers the formation of blood clots. Now, how did you get that? Well, aging, oxidative stress, poor diet, poor nutrition, exposed to toxic chemicals, smoking, which is full of toxic chemicals. So there's a lot of ways by which your blood vessel walls create and develop this damage. And that also goes for forming blood clots in your legs as well. Embolism, blood clots and embolism. Just a blood clot in itself is a thrombus. But if you get a piece of that blood clot break away and travel through the body elsewhere, that's an embolus. So it still came from an original clot. It's just landed somewhere else and caused some serious damage, as in the lungs with pulmonary embolism, etc. So, yeah, there's many things, and they always are going to go back to the same big picture, health-promoting or disease-promoting activities. Right. Okay, what's a disease-promoting activity? Smoke. Live in an asbestos-riddled building. Be susceptible to some serious infections that can cause some serious damage. Poor diet, exposure to all manner of chemicals and, even colorings and flavorings. They're all insults to the body that it was not designed to cope with. So, there's a whole lot of reasons that factor in to disease processes in any system, let alone the cardiovascular system.
Right. It always comes back to lifestyle after all, doesn't it? A question that comes to me is it inherited? Are there some conditions that we have some inheritance?
Well, the first thing I would say about genetic predisposition, even if there is, didn't it start somewhere? So was there a person in your family tree where they were not genetically predisposed, but they got it? So keep that in mind first. The answer is yes, of course. It has to start somewhere. But having said that, once something is running in the family, then yes, you are. But that is not a foregone conclusion. In most cases, that you will get that same disease. In most cases, there are some that are absolute. They're there from birth. But in other cases, it's yes, there was high blood pressure, cardiovascular disease running in the family, and I'd hasten to add in the next couple of generations, it will be in everyone's family because it's rampant around the world because of poor lifestyle, poor diet, obesity, smoking, etc., etc. It'll be in everyone's genetic pathway. Then really, it's the epigenetics. It's what are you now going to do to prevent that becoming a dominant problem that you will get. And you're back to where we started again. You're back to don't follow your parents' lifestyle. Don't smoke. Don't eat necessarily the things in their diet that are not so good. Eat more plant-based, more fruit, more vegetables, organic, etc., etc., etc. People know the answers to this. They just don't connect the dots. And often they just don't necessarily want to make the effort to change. Because change is an effort. But the fact is, change will also set you free, including from, in many cases, your genetic predisposition. So yes, things can run in families, and yes, it can be changed.
Beautiful. We love that. Now, again, the redox connection. So we learned in a previous episode that with redox signaling molecules are present in the cardiovascular system. So, and that our heart runs, as we know, on redox signaling molecules too. So we know that they have a role. Now, one is preventive, and we've spoken about that. How can we prevent dysfunctions and disorders in the system? But others, can we fix it? So where does redox come in if I have had a stroke or I have been ill? How can we repair?
Before I go there, can I just broaden the disorder topic? Because we talked about really one disorder, clots. But remember, you've got that muscular layer of the heart, the myocardium, that does a lot of pumping. Well, there's a lot of cardiomyopathies, which are disease processes that affect that myocardium. There's also that hardening of the arterial walls can also happen around the endothelium that forms the valves of the heart. And therefore those valves become stiff and stenosed. Stenosed means narrow. Well, that's going to obviously affect the passage of blood from one chamber to another, which then the valve is having to pump harder to get the blood through, so the heart gets enlarged. People have heard of an enlarged heart. Your heart will enlarge if you have high blood pressure for long enough. Why? Just imagine the heart's having to work harder to pump against that resistance because the blood pressure's up. So, you know, there are a lot of other issues. And the one thing perhaps I didn't mention before that should be mentioned is the electrics run the heart. The heart in itself has that myocardium for pumping, but what coordinates the contraction and relaxation in these chambers? Well, that's the nervous system. And of course, that's wired in these chambers into the myocardium to regulate contraction and relaxation cycles. So most people have heard of a pacemaker, but they hear of it more when somebody gets one surgically implanted. What they don't realise, well, you have one or two. And you only need a replacement if yours isn't working too good.
Right.
So the autonomic nervous system via the sympathetic and parasympathetic division is wired into the sinoatrial node of the right atria, which is the upper right receiving chamber. It is the main pacemaker of the cardiac cycle, which means when the atria relax, they fill with blood. And of course, while the atria are relaxing and filling with blood, the ventricles below are contracting and pumping the blood out to then receive the blood that's going to come down from the atria. So all that has to be coordinated through what's referred to as the conduction system of the heart, which I teach as the electrics. Okay. So you also have disorders of the electrics. So there's a lot of people out there with, you know, atrial fibrillation and ventricular fibrillation and palpitations and, you know, coordination contraction problems in their heart cycles. That comes from the conduction system, which is entirely different to the muscular myocardial part of the heart. So I just wanted to say there's a whole lot of disorders across all of these layers. Now, getting back to your question on can we reverse damage? Well, the answer is yes, you can. You know, we see extraordinary reversals of damage regularly in my practice. But of course, the older you are, the more damage that has occurred, well, the less you can reverse that damage. And you know, so therefore how far is going to be, how long is a piece of string? You know, it depends on how serious the person is in their lifestyle changes, whether they take the bio-replenishment supplement formula that's now available that contains redox signaling molecules to replenish them because everyone's deficient beyond peak puberty. So if you do those things and you change your diet and lifestyle and get some more exercise, then literally you are reversing the damage. And I've seen great reversals of some serious damage in the cardiovascular system over months, you know, over and more over a few years. You know, things that really shouldn't reverse with age, like, you know, high blood pressure, hypertension, which we haven't even discussed, but that's part of the problem. I've seen reversals over years completely, where no more drug medications were necessary anymore. Well, that literally means the elasticity is returning to those arterial walls. The atheroma is breaking down and reversing in the arteriosclerosis. You know, the myocardial muscle failures can be rejuvenated, but it's all by degree until a point based on age and how serious that person was compromised when they began their health journey.
Wonderful. Thank you for answering that question, and also for giving hope, because this is what's so inspiring and reassuring is that the science and technologies are proceeding in a way that they are supporting. Of course, we take responsibility for our health. There's no magic pill that will do everything for us if we don't take responsibility and work with our bodies instead of against them. Wonderful, very interesting, and of course, we've just touched the tip of the iceberg with disorders. We will come back to this topic because we know that it is a very important topic. But for now, thank you, Dr. Ray, for your valuable time. And remember, healthy cells, healthy you, happy you. See you next time. Thank you.
Bye-bye.